Thanks for skipping lunch to see me. I'm going to talk about Rapture, primarily the JSON part of the library. Who here knows anything about Rapture? Okay, not a few, not everyone. So Rapture is a JSON library, yet another of many for Scala, but hopefully I'm going to show some slides today really quickly that will show that the API is maybe nicer, more intuitive, more expressive than what you've maybe seen so far. Who here is using JSON in some way? So pretty much everyone. Okay, I'm going to do this in the form of one-liners. So there is a line of code. This is something you might type into the REPL, and that there is the result you might get back. So I've got about 20 of these slides. Normally I do about 50, and I do them in the space of 40-odd minutes, maybe an hour. So I'm going to rush through them today. This is a talk I'm quite familiar with because I've done it about 10 times in the last couple of weeks. But I've shuffled the slides for today, and I've cut some out, so every slide will be a surprise to me. And I will attempt to describe what's happening slide by slide. So this is actually part of Rapture.io, the IO library that is related to Rapture JSON, but is a separate thing. This is the first and last thing we'll see from Rapture.io. I'm going to grab a URL, slurp it as characters, which means pull all the data into memory, and store that in a string. That's how you do it. You describe the URI there. We call this slurp method, and we get a string. And the result is this string here, which we can probably see is some JSON. That's still a string. We want to get some JSON from it. So we would parse it using JSON.parse. Nothing too surprising there, I hope. We put exactly the same result. It looks the same, except it's now being parsed. There is a structure behind that, and it is valid JSON, at least well formed. Now, we've got the result JSON there, and I'm going to try and access something called canvas on that JSON. Now, that seems a bit weird, possibly, because it's accessing what is the key that's dynamically part of the JSON, yet I'm accessing it as if it's a static method. This works fine because we're using Scala's dynamic traits. So this allows us to get the nice syntax, which is basically equivalent to what you would write in JavaScript. You can call .candidates, you can call whatever key in an object, and it will dereference the object and you'll get something like that. In this case, it's an array. So we can access the first element of the array. It does the same thing. We've now indexed into that array. We've got this value here. Note that the type is JSON. Every operation we do, like indexing into an array or accessing a key in an object, will return something of type JSON. We're working with a dynamic language, JSON, within the static language, Scala. So for the purpose of calling these methods here and accessing these elements, we're putting aside static type checking. We're saying this is fine, it's okay. Let's try it. We can call .name. All the examples so far they've worked because, as it turns out, the dynamic JSON we've tried to access does have values in those places, and so we can get this result here. Now this is a string, hopefully quite obviously, except the type is still JSON. So we can't call any methods on a string like this. We can't pass this to a method that's expecting a string as a parameter because it's still typed as JSON. It's still in the dynamic world of JSON. We need to move it into the static world of Scala. And we do that by specifying the type. So we say .as, and we specify the type we want to extract from that piece of JSON. This will work fine because, as you saw before, it was genuinely a string, so we get a string out. Likewise, if we want to get the age, we can get that as an int. So we can extract a string, we can extract an int, we can also get a boolean, we can get nulls, we can get all the primitive types. What happens if we do this? Now this element clearly doesn't exist. And even if it did exist, it wouldn't have a foo, which has a bar, which has a bat on it. This is not something that exists. But we don't know that until runtime. what we actually get, we don't get an exception thrown, we don't get some kind of error returned, but toString, if you call toString on that, it will return the word undefined. Now, why am I just ignoring errors like this? Well, I don't really want to have to handle errors here. You can have an error when you try and access the 1000th element. I don't want to handle errors here as well, and here and here. I don't want to rewrite that code every single time for every single access. Instead, I want to do it once at the point I call as. So at the point I move from the dynamic world, where errors are more acceptable, into the static world, where they're not. This is the one single point where we can get failure. And we get a good error message there. We get a missing value exception. And it tells us exactly where the first failure is, on the 1000th element. And that is the first place it fell. It didn't even get to try these. So we get nice error messages in Rapture. The name and the age together make up a candidate. So if we specify a case class like this, we can extract directly from our JSON into a candidate object, just by virtue of that case class existing. Now, all the parameters of the case class must themselves be extractable. But if that's the case, we're perfectly able to do this. This will compile. And we can even get a list of them. So list is one of a variety of collections in Scala. You get a list. You could get something really obscure like a stack, or even a hash tag. So any collection type in Scala which has a can build from implementation can be extracted from an array in JSON, and we get the appropriate result there. We can go one further. So remember I said that all the parameters of the case class must themselves be extractable. We've got a gear value, that's obviously extractable, it's an int. And we've got an index sequence of candidates. Well, candidate is extractable. Therefore, index sequence of candidates is extractable. And because both of these parameters are, we can extract the whole case class. This is checked at compile time. So if you try and extract an election, and the election has some parameter that wasn't extractable, this would be a compile error, not a runtime error. As it turns out, we can just take our JSON, our parsed JSON, and in one line we can extract the entire statically typed case class structure. And this is what we get here. So that's quite a neat. I mean, just by defining two case classes and writing this line here, we've extracted all of that. About halfway through. So error messages, or errors in general, can occur. I'm going to very briefly, without much explanation, explain how Rapture allows you to handle them. By default, if you try and access something that is that throws an error, so the value is missing or it's the wrong site, you get an exception. Now, exceptions are fine if you're working in the REPL, but in production you probably don't want exceptions being thrown around all over the place. So what you can do is you can add this import to your code, and every fallible method, for example, extracting into an election case class, will return a try instead, like this. So we do JSON.as election. This is exactly the same code as before, but now that import is in scope, we get a try of election instead with the success type there. Return try is just one possibility. We can actually do everything in a. We can do the operation in a thread call. So if we import most or return features, this will magically be run. Almost magically. It's not real magic. It's using types. It's using no macros. It's using high-kinded types, dependent method types, and implicits. But it probably seems like magic. The API will change so that we get a future instead of the just the raw election, the raw election result, or getting the try. Modes are more general than that. We can actually import this one, modes.time execution. If we wanted to see how long something took, we import that. This is exactly the same code as before, and now we're getting an election tuple with a long as well. That is the number of milliseconds that have passed since we've been starting the operation and finishing it. So it runs that in 14 milliseconds. Okay, that was probably the briefest explanation of modes I've done. There's a load more information on that. If you want to find out, speak to me afterwards, because I think it's a really cool idea, and I would love to talk about it some more. And I'd love to have you using modes in your own software. We could write a JSON literal like this. This is pretty easy. We just put the JSON inside quotes and we prefix it with the word JSON. This is a lot like an interpolated string. So we have this additional prefix in front of the string there, and we get additional checking done at compile time. So this will be checked to make sure it is valid JSON. If you miss a quote off, that's a compile time error, not a runtime error. We can even substitute values in. So in the same way you can with a string, an interpolated string, we can put this value in here, and it will be transformed into this object here. So any objects you can extract from JSON, pretty much you can serialize back to JSON. So this was a case of this is the value we extracted before. We're actually putting it straight back inside behind the vote key, and it will appear there like that. This is all type safe. You can't put something in there that won't actually serialize. We can do a pattern match on JSON as well. So this is a bit like the JSON literal we wrote before, except it's being written as the pattern match on a case clause. What this is saying is our vote JSON here, does it match the structure I've defined here? Is it an object with a key called vote, which itself has a key called name? And if so, the value at name will be extracted into the value C, the identifier C, and we refer to it here if the match works. If it doesn't, we get a match error because there's no catch-all. I haven't actually written a JSON parser. I haven't written a JSON backend. There's no AST in Rapture, so I use other people's. I'm going to go through these really quickly. These are all available as backends for Rapture. Who uses the ScalaJSON standard library parser? Hands up. Nobody. Good news. Does anyone use Jackson? Cheers for Jackson. Yeah. Okay. JSON Press. Okay, a few more for JSON Press, or at least a few more people willing to admit it. Spray. Yeah. Okay. It's quite a mixture here. Lift. 2 people using Lift. Okay. I'm glad I bothered with that then. Argonaut. Just one for Argonaut. Okay. There's a lot of variation in the various places I've given this talk. Does anyone know Jawn? Nobody ever uses Jawn. Jawn is Eric Osheim's JSON parser and library. It's really, really fast. It's sometimes faster than Jackson, so I can recommend that as the backend you should use. I have 2 minutes left. I'm going to talk about mutable JSON. So, like list has a mutable counterpart called list buffer, the JSON type has a mutable counterpart called JSON buffer. We can create an empty one like that. We can add a value to that JSON buffer. Our vote is going to be Bill Clinton, carrying on the theme from before. We can specify the candidates and Democrats. So this is actually automatically creating the candidate object, and within it, the Democrat object, and we're going to serialize this case class here, which I've just created in place, and that will be put straight into the JSON buffer there like that. And when we've done that, there is one more slide on Rapture.io. We can write that JSON buffer straight to disk. So with one line, that will be saved onto disk. And I have actually done this with 1 minute to spare, which I didn't expect to do. Are there any questions? Yeah.
Is there a possibility of a Rapture LD version?
Yeah, talking afterwards. I would love to discuss that. Yeah.
Write 2 will also post to your URI. If you want to post JSON to.
If you want to post it to
REST API.
Yeah. That is not currently available in Rapture.io, but it is something I'd like to add. Yeah. So you can actually just have a JSON value which you post. It works out the MIME type that's appropriate to the post and creates that. Yeah, that's possible. Sorry?
That would be quite handy for tests.
Yeah. Okay, I will raise an issue on that and get around to it. I've got 30 seconds left, maybe. questions? Was that okay? Too fast?
Great.
Okay. Cool.